Hello everyone, my name is Javed Malik, and this course which we are offering is based on uh, the hazard related to uh, the seismic shaking and all that. This is the course which we call as earthquake geology. Okay. So in this course we will be having two TAs with us, and the details are there in the next slide you will see. And of course, we will also get through the office, the details of this two TAs. It's my PhD students, Mittu Dhali and Monica. So they will be helping you at various stages. Okay. Now, this course, as I told, that is extremely important for the country like India, actually, and because India is vulnerable to earthquakes at number of locations, and I would say location, not location, but the zones. Okay, so we have Himalayas, we have Andaman Nicobar, we have Kutch region, and nevertheless the other portion of Indian plate, okay, which we believed earlier that those areas are stable areas because they are composed of very hard rocks, and they are uh, like they will not have any earthquake, those areas will not have any earthquake, or they will not produce any earthquakes, but it happened actually. Okay, and there were earthquakes like Latur earthquake, then we had an Koina earthquake in that region. And if we dig into the history of the earthquakes, the records which are available with us, that clearly indicates that those areas were also uh, have, have experienced the earthquakes in the past. Okay, but broadly, if we look at, we have three major areas or the zones which falls in zone 4 and 5, and we will talk about this, that what are these seismic zones and all that. But these are most vulnerable areas like Himalaya, and then you have Andaman Nicobar, as I told, Kutch also. And these areas uh, are not just going to be the vulnerable, but the adjoining regions. Okay, like for example, we are having the Himalayas and adjoining areas in the foothills, and further down south we have Indo-Gangetic Plain. So those areas are also vulnerable because of the strong seismic shaking. Earthquake might occur in Himalaya and will occur in Himalaya, but the effect will be far field. Okay, so that part also we will learn, and why this earthquake geology part is so important to be studied, and why it is considered as a tool for seismic hazard assessment. We may not get into a typical seismic hazard assessment in this course. We will peripherally we will touch that part, but we will learn and more about the that how we identify the historical earthquakes. Okay, now historical earthquakes doesn't mean that those are just recorded in the historical chronicles. Okay, so the written records may not be complete. We might have missed many earthquakes. So mostly what earthquakes we see in India and the records which we see, those are available. Okay, or we can say that those were been saved from multiple invasion and to our country. So there are the eras, we can say, the rulers who ruled India, and then who, so there are some eras which are like, we have a lot of good records of the medieval time. Okay, and then the British time also we have few, but most of the records are not available. Now, let us not get into that detail and then emphasize much on that. But whatever, for example, the like say 2000 years back, okay, or 3000 years back, or 4000 years back, whether there were earthquakes in this region or not. Because why the question always comes is that why we want to go so many years back and try to find out the evidence of the earthquakes, because this regions which are under continuous pressure, I would say, I am using a very simplified word, or I would say that they are under stress. Okay, like Himalaya is under stress, the Indian plate is under stress. Okay, So why we want to go back into like 4,000, 5,000 years back? Even I can say that we need to go back up to 10,000 years or more, because the recurrence cycle of such earthquakes is larger. Particularly in Himalaya, it requires almost like 700 to 800 years. So whether in the past similar type of earthquakes have occurred or not, now recent, if like news, if you might have come across, then there was recent earthquake in Myanmar, and that has resulted into devastation in not just in Myanmar region, but far field, okay, far field in Bangkok and all that. Okay, so we have also tried to show you that part in the beginning in this introductory lecture, and slowly we will talk about that. Uh, just like the based on the occurrence of earthquake, what is the hazard posed to the citizens of India and at different locations, and what are the secondary effects? Okay, like as I mentioned, and I will keep on having some, this part will, I will keep on emphasizing again and again when we are talking about the particular topic. Like for example, you take Andaman part. Andaman, we experienced 2004 tsunami, earthquake plus tsunami. Okay, so this the process remains the same actually in Himalaya, in Andaman, and then coming to Gujarat also, I'll come to that. So the process is the plate tectonics, okay, plate deformation, and we can say that you are having the plate boundaries. Okay, so what are these plate boundaries? How seismicity is distributed? What is the importance of understanding the seismicity and all that? Okay, and what are the primary and secondary associated hazards and how far it can affect? Okay, so that was, people will say, I'm staying in Himalaya, and other will say that, oh, I'm staying in far away from the Himalayan region. Okay, maybe 400, 500 kilometers away. So I'm not going to be affected by an earthquake which is occurring there. Similarly, someone say that, oh, I'm staying in the east coast, along the east coast of India. So whatever happens in Andaman, why should I bother? Okay, but that has taught us a lesson. Okay, in 2004, the Chennai area was, of course, which was highlighted more, but the east coast of Himalaya, of Indian plate or the Indian subcontinent was affected by 2004 tsunami. So we can't say that, okay, if the event is occurring somewhere, we will not be affected. Okay, so we need to do that. We need to understand the hazard. Then what level of hazard it will be. Okay, so that sort of things we will be talking in this course. So I welcome you all for this course, and we will try our best. And another component which we have added in this one is that we will also try our best to put the live videos which the recording we have done while doing uh, the the field investigations, okay, in Himalayas. I might be having some videos from Andaman. I'll try to do that, but we are certain that we are going to put that also. So you will also learn that what we do in field, how we how much time we give in field, and how we identify the landforms, how we try to collect the data which is preserved on surface and within the surface, that is within subsurface, we can say near subsurface. We don't go much deeper than like kilometers. Okay, just we are looking at for the evidence at the surface. Okay, but that is more than enough for hazard assessment. Okay, another part which I would like to emphasize here is that IIT Kanpur, along with other institutions, uh, has done a government flagship project under which we are going to come up with an active fault atlas of India. That will be the first atlas of India, which is highlighting the active fault traces. Okay, and that was the attempt which we thought of, and that was, I would say, that the dream project we wanted to do for our country. Okay, and it is not that we are the first to do similar like that sort of work in India. Other countries have already they had this type of active fault maps, but we wanted to do for India. So, we wanted to have a basic or I would say the fundamental aim behind this was to provide a safer environment to our citizens, minimize the risk part. Okay. We can't stop the earthquake, we can't stop the tsunamis, occurrence of the tsunamis, but we can minimize this hazard. Okay. So, we know better, we can have better safety protocols. Okay. So, let us move ahead in this course and what we have in sort of in course content. So, we will talk about the crustal deformation and associated earthquakes in this course. Plus, we will talk about what is the significance of the seismicity. Seismicity means we are talking about the earthquake occurrence. Okay, at particular in particular area, and what is the sort of an alignment and what that alignment or the orientation of that seismicity is trying to tell us, actually, that we would like to understand from this. Okay. Then the identification of the prehistorical earthquakes. Okay. And this is based on the primary and secondary structures. Okay. Now, as I told and if you just try to look at the top the title of the course, it talks about earthquake geology. So, we are not going to leave the earth science from this. Okay. We are going to deal with the sediments, we are going to deal with the landforms, and we will also deal with the environment in which those sediments were been deposited and later on got deformed. Okay, because of the tectonic activity. Now, those are the words which you will also slowly come across and learn that what exactly we are talking about. The tectonics, what do you mean by tectonics? Tectonic is basically we are talking about the deformation going on this planet, actually, and that deformation, why it happens, why we are interested in looking at the plate tectonic part, and plus learning about the plate motions. Okay. So, we will talk about that part also. Now, I will just mention here that our Indian plate is not stable, it is moving continuously with a sign of a particular velocity. Okay. It moves like 45 to 50 millimeter per year towards Tibet. Okay. And that collision between the Tibetan plate and the Indian plate is creating a pressure, that is what we call the development of strain. Okay. And that the reason behind the formation of Himalaya goes like for we can say that this is the testimony of what we see the plate collision. Okay. We will talk about that part also. Then, so the other part is like identification of the prehistorical earthquake based on the primary and secondary structures, signatures. That means we will try to understand that whether this the sections exposed geological sections, basically what structures they are showing, whether they are sedimentary structures, because there are some structures, primary structures or the signatures which we say that they got during the or they were formed during the deposition. Okay. So, whether those are erosional depositional structures or they are tectonic structures later on got deformed. Okay. So, we need to have understanding of that. Similarly, identification, interpretation of active faults and associated landforms. Okay. Because there are many landforms which will mimic like or which will be very much similar to the non-tectonic processes. Okay. So, we need to have that understanding how we are going to differentiate between this type of landforms, whether it is tectonic or not, or whether it is purely tectonic. Okay. So, that part will be there. Then, so as soon as you say that okay, landforms, then how you are going to identify the landforms, that is again important, and for this you need to have what we call photogeological mapping. Okay. So, we will also try to put here, after we understand about the landforms, we also will put here that okay, how we are going to use remote sensing. Okay. So, you are going to use remote sensing technique here. So, we will also try to have one or two labs on this, actually. Okay. Where either me or TAs will be involved in explaining that how we are going to use and what are the data we are going to use. Probably we will try to give you the assignment on that. Okay. So, that is one point we can do. Now, another here photogeological. So, we are going to use to identify the landforms, we are going to use the photogeological mapping we will do, or you can say remote sensing mapping, but we are going to use high resolution satellite data here, and that is must. Okay. Now, there are ways, more techniques are available, more methodologies are available. As science grows, we are getting more robust in and more like equipped with the technology. Okay. So, you can use UAV also here, all unmanned aerial vehicle to map this areas. Okay, and have a very detailed map. You can use lidar also to have like digital elevation model, DSM you can generate with UAV photographs and all that. But another part which is associated with this topic will be the identification of tectonically formed landforms or tectonically developed landforms on fault and off fault. So, what are faults? We will talk about that first. Okay. So, and then, so if we say that this line is a fault line, okay. So, then what are the evidence you are supposed to see here that will be on fault, and what are the evidence or signatures you are supposed to see far away? Those are the, we say, landforms of fault. Okay. And at some like instances, what you will find is that if you will say that the deformation is taking place along this line. Okay. So, why we want to see the off fault evidence or the signatures? Okay. Because in long term, this deformation is going to affect the overall processes up on the upper side and the lower side, or the upper reaches and the lower reaches of this fault line. Okay. So, that is very much important for us to understand that what is the what will be the effect of this deformation. So, the important point what I want to mention here, that other than this identification and all that, we have seen that there are long term effects on the environmental part also. Okay. So, for example, if I say that the Himalaya is a result of this type of deformation and multiple giant earthquakes or the great earthquakes have been triggered in the past to bring up this gigantic or mighty Himalayan range. Okay. So, what it has given to us? It has given climate, that is your or we can say the seasons, monsoon. Earlier we never had monsoons. Then fertile land which we got is because of the deformation. Of course, the erosion took place, and then we had the deposition of the monsoon, then precipitation came because of that actually. Okay. So, we have advantages as well as disadvantages with such deformation going on. Okay. Himalaya deformation in Himalaya, the tectonic deformation in Himalaya has changed the landscape over time. Okay. So, that also we will try to understand here. We will show you a couple of examples of case studies where we are not only just talking about the seismic hazard, but we are talking about the long term effect on the environment as well as the human settlements. Okay. That part also we will try to put that. Okay. Now, the another word which will keep coming again and again, I am going to always talk about this, is the active faults. Okay. And this active faults we will talk about that how we identify this, how and what are the criterias you are going to adopt, and what knowledge you are going to keep in your backpack when you go for the field or you go for such studies. Okay. So, this is what exactly we will do here. Further, this is, as I told, that we will be talking about the field techniques. So, quantification of active fault scarps by precise mapping. So, mapping tools also we will try to teach you. Okay. Precise mapping, maybe we can say at centimeter level, or we can go for the millimeter level mapping. A very high resolution mapping has to be done if you want to talk about that, the hazard and all that. Okay, in future, identification of old, that is prehistoric prehistoric, why we are talking about, because probably what data we have with us is the historical chronicles or data in the written records. Okay, but what about the before that? Okay, we might not be there, but those evidence or the signatures are preserved in landforms, okay, in sediments. So that is the beauty of this type of studies. Okay, so you can go back into the history and then of that, okay, before prehistorical, or maybe you can say before the humans came in. Okay, so that also, because the industrial revolution and all that which started, and the development of scientific world started at around 10,000 years. So before that, what has happened? Okay, but at least to 10,000 years if you are sticking also, that is more than enough for us. Okay, so we do that using like trenching. So we dig or we excavate the landforms to see the sections, okay, to see the sediments which are going to tell us about the signatures which are preserved there. Okay, so we try to do that, and so that part we will also we have recorded in as a field technique. We'll try to uh, tell you about that, how we do all this type of studies. Okay, and as I told that the what portion of the crust is deformed, is getting deformed. Of course, these faults are deep seated, some faults are shallow faults, and they along which the deformation is taking place. So basically, whatever material is available on the I would say thin veneer of crust, okay, will deformed and it's getting deformed. Okay, so we usually try to see the young deposits and young material deposited by in different environments. So that what we call the sedimentary succession. Okay, so we will try to show that how we map this, and what is the basic knowledge we need to have with us to differentiate this primary and secondary structures. Okay, so suppose if I say that, okay, fine, there is a deposition of the material here. Okay, so then we have like sand, then we have clay material, and then we have like silt and all that. Okay, so once you apply the force to this, okay, and that force is coming from tectonic movements. Okay, so then this will get deformed. Okay, so you will have multiple layers which are getting deformed. Okay, so this uh, differentiation of this type of deformed structures we are going to uh, learn, and that will be helpful for us to understand that whether this is tectonic or non-tectonic. Okay, so as such, this will we will call primary, okay, structure, and this will be your primary structure, as we are talking about the and sorry, and this will be your secondary structures. Okay, so this part we will learn when we are talking about the primary and secondary structures. Further, if we talk about, then what we say that, okay, fine, we will also consider from trench, we will also try to look at that how much this sediments or the sedimentary units have been displaced, okay, during one single event. Okay, now how we are going to identify the single event, that also we will learn. Here we are talking about events, means our earthquakes. Okay, single earthquake. So as we say that this faults are active, then it is understood that this faults have experienced earthquakes in the past, the displacement in the past, and in future also there will be an earthquake along this fault. Okay, so those things we will talk about, and that helps us in talking about or identifying the slip rate. So how we are going to do that, that also will done. Other than that, we will also try to compare, like after having the ages to the sedimentary units. So we are also going to talk about the dating technique. Okay, dating is not this that dating, this dating is the numerical dating. We'll use sediments and the energy which has been acquired by the sediments. We do optical illumination simulation dating, and then another one is carbon 14. So, we will talk about that also. So, till now we will stop here. Thank you so much. See you soon in the next lecture. Thank you.